Hello dear students, in this lesson I'm going to talking about isosceles and equilateral triangles. First of all, I'm going to talking about the isosceles triangle theorem. In an isosceles triangle, base angles are congruent. It means in triangle we have three angles. These two angles are congruent because these two angles are the base of the angles for this triangle. So we can say the angle B is congruent to the angle C. Base angles are congruent, and then the perpendicular bisector of the base in the same times altitude. It means this line segment is a perpendicular bisector for the base, and in the same times altitude. First, this perpendicular bisector, it means MC is congruent or equal to MB, and then this perpendicular bisector is the same times is altitude. Altitude, it means what a berzi. What are am perpendicular bisector height triangle که يعني بۆ ناگر مێژەری ئەم perpendicular bisector بزانی ئەو کاتە ئەزانی کە triangle چەندێک بەرزە. And median. واتاڵێ مە هەم mediani triangle کەشەوە ئەم perpendicular bisector کە ناوڕاستی triangle کەوە. And bisector of the vertex angles. It means this perpendicular bisector bisect these angles into two equal parts. Wata am angle kردو بدو بەش یەکسانەوە بە جۆرێک هەردووکیان equalن. Wata ئەگەر ئەمە بۆ نمونە 45 بێ ئەمەشیان بە هەمان شێوە 45 یا بۆ نەماگەر 30 بێ ئەوشیان بە هەمان شێوە 30 واتە کردوێتی بە دوو بەش یەکسانەوە بیسەکتی کردووە. After that, we have this example. For this figure, we have some informations. MASR is a rhombus. MASR is a rhombus. We have to prove that the measure of angle 1 is congruent to angle 2, and the measure of angle 2 is congruent to 3, 3 congruent to 4. First of all, we can say the triangle of MAR is an isosceles triangle. The triangle MAR is an isosceles triangle. So the measure of angle 1 is congruent to the measure of angle 4, because in isosceles triangle the base of the angles are congruent. And then this triangle ASR, or the triangle ARS or ASR, is an isosceles triangle also. So the base of the angles are congruent. It means the measure of angle 2 is congruent to the measure of angle 3. After that, we can say AM is equal to AS. AM equal to AS, and we can say MR or RM equal to RS. So AR is a perpendicular bisector of MS. AR is the perpendicular bisector of this line segment MS. So you can say IR is a perpendicular bisector of MS. So we can say AR bisect the angle MAS. AR is bisect the angles MAS. AR or RA is bisect this angle MAS. So the measure of angle 1 is equal to the measure of angle 2 because this angle is bisected, and then the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 1 is equal to the angle 4, and the angle 2 is equal to the angle 3. It means we can say the measure of angle 1 equal to the angle 2 and angle 3 and equal to the measure of angle 4. After that, we have this figure, we have this triangle. We have to prove that the measure of LK equal to the measure of LM. It means we have to prove that this triangle is isosceles triangle. So the measure of angle LMK is 89.6. Measure of angle LMK equal to 89.6 degree, and then we have to find the measure of angle LKM to know the base of the angles for this triangle are congruent or not. So we have the measure of angle LK. So the measure of LK equal to, for example, we have to write a point here like P. So the measure of angle LKP equal to 90.4. For finding the measure of angle LKM, this is a straight line. When we add these two angles, always we get 180. So we have the measure of angle LKP. LKP is 90.4. 90.4 plus the measure of angle LKM. We don't have the value for LKM, equal to 180 because these two angles are on the straight line. So we have to subtract these two numbers for finding the measure of angle LKM. So 180 minus 90.4. You have to subtract it, and then you have to write a small point and 0. This 0 become 10, and this 8 becomes 7. The 0 become 10, and then become 9. 10 minus 4 is 6. 9 minus 0 is 9, and then this 7 becomes 17, and this 1 becomes 0. 17 minus 9 is 8. So the measure of LKM equal to 89.6 degree. So the measure of LKM is also equal to 89.6, and the measure of LMK is 89.6. It means this triangle the triangle LMK is an isosceles triangle. The base of the angles are congruent. So we can say the measure of length LK equal to the measure of length LM. After that, we have this example. We have this triangle. We have to find the measure of angle L. The measure of angle L we have by expression, we have 4x, and the measure of angle M is 2x. First of all, we can say this triangle LMB is an isosceles triangle because these two sides are equal, because the length of LM is equal to the length of LB. So because we have an isosceles triangle, the base of the angles are congruent. It means the angle of M is 2x, also the angle of B is 2x. Now, for finding the measure of angle L, we can say the measure of angle L plus the measure of angle M plus the measure of angle B equal to 180, because the sum of the measure of the interior angle in triangle equal to 180. So the measure of angle L is 4x plus the measure of angle M is 2x plus the measure of angle B is 2x equal to 180. 4 plus 2 is 6, 6 plus 2 is 8, x equal to 180. We have to divide both sides by 8. These two 8's are reduced, so x is equal to 180 divided by 8 equal to 22.5. The value for the x is 22.5. And then the measure of angle L equal to 4x. So we have 4 times the value for x is 22.5. 4 times 22.5 equal to 90 degrees. So the value for the measure of angle L equal to 90 degrees. After that, we have this triangle, and we have some information about this triangle. M is midpoint of CD. This point is midpoint of CD, and then the measure of angle 1 is congruent to the measure of angle 2, and the measure of angle D is 72. Find the measure of angle 1. So we can say the triangle CDB is an isosceles triangle. So the base of the angles are congruent. The measure of angle D is 72 degrees, so the measure of angle C is 72. The base of the angles are congruent. So we can say the measure of angle D equal to 72, and then equal to the measure of angle C. After that, for finding the measure of angle B, the measure of angle C plus the measure of angle D plus the measure of angle B equal to 180. The measure of angle C is 72 plus 72 plus the measure of angle B equal to 180. 72 plus 72 equal to 144 plus the measure of angle B equal to 180, and then we have to subtract these two numbers for finding the measure of angle B. 180 minus 144, the measure of angle B equal to 180 minus 144 equal to 36. So the measure of angle B is 36, and then M is midpoint of CD. It means M is the perpendicular bisector of this angle, angle B. So the angle 1 is equal to the angle 2, and the angle B, when we divide by 2, we will get the measure of angle 1 and 2. So the measure of angle 1 equal to the measure of angle B divided by 2. The measure of angle B is 36 divided by 2 is 18. So the measure of angle 1 equal to the measure of angle 2 equal to 18 degree. After that, in the second part of this lesson, I'm going to talking about the properties of equilateral triangle. In any triangles, in any equilateral triangle, the angles of an equilateral triangles are all congruent. Always we have three angles in triangle. In equilateral triangle, the angles always are congruent. It means, for example, this angle is A, B, C. The angle of A always equal to the angle of B and equal to the angle of C, and always equal to 60 degree each one of them. After that, if all the angles of a triangle are congruent, then it is equilateral. And then in equilateral triangle, all sides are congruent. It means the length of AB equal to the length of AC and equal to the length of CB. After that, we have this example, we have this triangle, we have to find the value of x. And the measure of angle C we have by expressions 3x plus 15. And this triangle is equilateral triangle because all sides are congruent. We have one line for all sides, so we can say triangle ABC is an equilateral triangle, and then we can say the angles are congruent. So the angle C is 3x plus 15, and then the measure of the angles always equal to 60, so we can say 3x plus 15 equal to 60. 3x plus 15 equal to 60, and then we can combine the like terms. 3x equal to 60 minus 15. 3x equal to 60 minus 15 equal to 45. Now we have to divide both sides by 3. So x stay equal to 45 divided by 3 is 15. The value for x is 15. Example number 2, you have this triangle, you have to find the value of t. This triangle, triangle JKL is an equilateral triangle. So we can say the lengths of all sides are congruent. So JL, the line segment of JL is congruent to the line segment of KL. So we can say 2t plus 1 equal to 40 minus 8. we can combine the like terms. 2t and 40 become minus or negative 40 equal to minus 8 minus 1. 2t minus 40 equal to minus 2t. Minus times minus is plus. 8 plus 1 equal to 9 or negative 9. And then we have to divide both sides by negative 2. So the value for t equal to 9 out of 2. And 9 out of 2 equal to 4.5. The value for t is 4.5. After that, we have this example. We have this triangle. This triangle is an equilateral triangle. We have to find the value of y. The value of y is 12. We have 12 of y. So the measure of all angles are equal to 60. So we can say 12y equal to 60. We have to divide both sides by 12. So these two 12s are reduced. Y stay equal to 60 divided by 12 is 5. The value for y is 5. After that, we have this example is the last example. We have this triangle. We have to find the measure of MN, RN, NMR, and NRM. So first, I'm going to find the measure of line segment MN. Because of this triangle is an equilateral triangle, this triangle MRN is an equilateral triangle. So we can say MR is equal to MN because all sides are congruent in equilateral triangles. So we can say the measure of MR equal to the measure of MN equal to 3 centimeter. After that, I'm going to find the measure of R line segment RN. This is RN. So RF is 2 centimeter. The measure of RF equal to 2 centimeter. And then this perpendicular bisector is bisect of this side, the base of the side. So RF equal to FN. Because this triangle is an equilateral triangle, so RF is 2 and FN is 2. Now we have to add RF plus FN equal to RN. RF is 2 plus 2 equal to 4. So the length of RN equal to 4 centimeter. After that, I'm gonna find the measure of angle NMR. NMR. So FM, we can say FM is bisect. FM is bisect the angle NMR, or we can say RMN, because this triangle is an isosceles triangle. So the measure of angle RMF is 50. RMF, the measure of angle RMF equal to 50 degrees. So equal to the measure of angle NMF. Equal to 50 degree. and then we have to add the measure of these two angles to know the measure of angle NMR. So we have the measure of angle RMF plus FMN equal to the measure of angle RMN. The sum of the measure of these two angles equal to the measure of angle RMN. The measure of angle RMF is 50. The measure of angle FMN is 50 equal to 100. So we can say the measure of angle RMN equal to 100 degree. After that, the last part of this example, you have to find the measure of angle NRM. NRM, the measure of this angle. So we can say the measure of angle M plus the measure of angle R plus the measure of angle N equal to 180, because the sum of the measure of the interior angles in triangle equal to 180. The measure of angle M is 100 plus, and then because this triangle is an isosceles triangle. Sorry, it's not an equilateral triangle. In the first part of this example, I said this triangle is isosceles, equilateral triangle, but this triangle is an isosceles triangle. So the base of the angles are congruent. It means instead of this two angles R and N, we can use the same variable because the base of the angles are congruent. So for measure of R we can write x, and for the measure of N we can write x equal to 180. So 100 plus x equal to 2x equal to 180. So 2x equal to 180. We have to change the place of positive 100 become negative 100. So 2x equal to 180 minus 100 equal to 80. And then we have to divide both by 2. These two 2's are reduced. X is equal to 80 divided by 2 is 40. So we can say the measure of angle R equal to the measure of angle N equal to 40 degree.